Hi everyone. Today we're going to talk some basic matrices. So we're just going to talk about a couple of the different types that you're likely to see on the exam. So just let me sort that out. So I guess this is sort of like an intro video if you're not really sure what a matrix is. So basically, I'll start from the beginning. So a matrix is it's a rectangular array that has some numbers in it. Okay. They usually come inside brackets that look like that, and you have numbers inside, and these numbers aren't separated by columns or columns. So they're not separated by commas, nothing like that. They just sort of have their own space, right? So they come in different shapes and sizes. So this can be a 2 by 2. You can obviously have one significantly bigger than that, or smaller, or whatever you need, right? Common one that people ask me is, can you have a 1 by 1 matrix? The answer is, of course you can. Right, like the 1 by 1 matrix, nice and easy. So they come in a whole bunch of different sizes, but there's a few examples that I want to go through, I guess, so you could wrap your head around it a bit more. Um, sorry. So let's start off with a square matrix. So square. So a square matrix is a matrix that has the same number of rows as it does columns. Right? So it can be a 1 by 1, a 2 by 2, 3 by 3, right? These are all considered square matrices because they fall into that category, right? Fill these in with some random numbers so you get an idea of what they look like, right? So that's a square matrix. We also have row and column. So a row matrix is a matrix that's made up of one row that can have as many columns as you need. Broke the pattern and went blue instead of red. Stuffed it up. So let's say you've got 1, 3, and 8. Right? That could be a row matrix or something like this. Anything that's just got one row is considered a row matrix, and presuming that you can follow some basic logic, you also have column matrices, which are one column, which makes a lot of sense if you think about it. You'll come across these a lot, as long as they've got as long as they've got one column and they can have as many rows as required, then it counts. Back. Yeah, so that's square, row, and column. We also have singular, which is a little more complicated. So this gets into what's called the determinant. But essentially, if you have, this is your matrix form. I'm just putting letters in to represent these elements. If you have a matrix that's, let's say, 2, 7, 14, and 1, right? A matrix is considered a singular matrix if A, so the top value, so A times D minus B times C is equal to 0. Okay? So this has to do with the inverses, which again we'll cover later on, but we can check and see that this works. So A times D, so 2 times 7 minus B times C, so 14 times 1. Give us 14 minus 14, which equals 0. So that means that it's a singular matrix, which means that there's no possible inverse for that, but we'll get into that in a few lessons from now. We also have identity matrix, and I'll write diagonal as well before I forget. That's probably not how you spell diagonal, but that's okay. So we have identity matrix, which essentially are a matrix that has a pattern like this, right? And the bigger that they get, they continue to follow that pattern. So all they are is they have ones down the diagonal, and the rest are all zeros. Okay. So, and the purpose of these is they essentially are the value of 1. So a matrix times this will stay exactly the same. All right. And a matrix multiplied by its inverse, which is, I guess, the equivalent of dividing, would equal an identity matrix. So essentially it's 1. And finally, a diagonal matrix is the same as an identity matrix, but instead of ones, it's some other value. So it could be 3 and 7, for example. All right. But these are essentially the exact same thing. All right. And you tend to use this in lieu of an identity matrix if you want to say change some values but not mess up that original matrix too much. So a good example would be if you wanted to increase prices by a certain amount, you could do an identity matrix, but instead of ones, you could have, say, if it was an increase of 50%, you could have 1.5, and that would do that job fine. I'm just going to jump on and check my notes. I think that's all the ones that I had written down. If you'll excuse me for just a second, I would recommend that if you're watching this on YouTube, that you just fast forward, say, 30 seconds. Let me make sure I got all this, all the different types down. Okay, I missed one. All right, so another one that we're going to talk about is zero matrix. And I guess for those of you playing along at home, you can probably guess that's just any matrix where all the elements are 0. All right, so that's pretty common as well. So they're the main ones. Let me flick over a page here. So recycling some old work. That's all right. So I'm going to flip over the page, and what I want to talk about now is, I guess, order and things like that. So if you have a matrix, all this stuff. Let's say you have a matrix that looks like this. All right. This matrix here is, that's a 9 if you can't tell. It's not very clear. That's all right. I guess it doesn't really fit into any of those categories. So one of the ways that we define a matrix is we talk about the order. So what order means, order, is you talk about how many rows there are times how many columns there are. But I don't want a sum. Okay, so I don't want, in this example, we have, so these are rows. So rows go sideways, right? Columns go up and down. Okay, so in this case, we have 1, 2, 3 rows and 1, 2 columns. So we have 3 by 2. And that's how that's read, not 3 times 2, 3 by 2. So I guess it should be said like this. All right? So you write this sum, and it means 3 by 2. I don't want you to write the answer 6, for example. However, if you do that sum, it'll tell you how many elements there are, which leads us on to the next thing. So elements, which are these things in here. They're all individual elements, all right? And the way that you tend to refer to an element is by what row it's in, comma, what column it's in. Okay? So in this example here, let's call this, this matrix can be called matrix A. If I wanted to know what was in matrix A, let's say I want to identify this 9, I would say row 2, comma, column 2. Nice and easy. So row 2, column 2 is 9. You could also say things like, let's say I wanted to do this 7, it would be row 3, column 1. If I wanted to do, say, something like this, though, the problem is that this element doesn't exist, right? There's a row 3, but there's no column 3. So I can't find that. So that's invalid. All right? That's the basic idea, I guess, of matrices and order and elements and that sort of stuff. So yeah, very basic video. Hopefully you enjoyed it, and hopefully it helps. Take it easy.